As we all know, there are a lot of impossible integrals, but don't worry, because we can take care of some of them with power series. In this video, I'll give you 6 examples, and this is the first one, the integral of sine of x to the third power. And let me tell you, the hardest part of this video is not the actual integration step, but rather we have to know how to find the power series for the function that we have here. So have a look on the side. Of course, we need to know the power series for sine of x. And let me show you guys how to remember this right here. Here, of course, you have the series and n goes from 0 to infinity. First off, we have to know that sine is an odd function. So you are going to see the odd factorial and also the odd power. And you have to remember that sine alternates. So we will go ahead and have the alternating factor, which is -1 to the nth power, and then divided by the odd factorial, which is 2n plus 1, and then now factorial that. And then we have x to the odd power, which is 2n plus 1. And this right here is a power series for sine x, center ds0. And we also should put down the radius of convergence, which is actually just infinity, which is very nice. Here we have the sine of x to the third power. So let's just go ahead and plug that in. So inside here, we just have x to the third power, and of course do the same thing here. So we have the series as n goes from 0 to infinity, and then just write this down again. -1 to the nth power over 2n plus 1, factorial that, and then this is x to the third power, and then raised to the 2n plus 1. What do we do next? This and that, we can just multiply the powers. And then yes, write this down one more time. And then 3 times all that, we get x to the 6n plus 3. And you see, we're just plugging x to the third power in here and here. And because radius of convergence is infinity, you know, take the cube root, whatever, it's still infinity, right? But yeah, so let's indicate that r is still infinity. Yeah, be careful with this sometimes, because if r is finite, you have to be really careful with what kind of algebraic thing that we are doing. So you will see that in the later video, like in the later example. Alright, so let's go ahead and integrate that. Ladies and gentlemen, here we have to integrate this, which is just that, and yes, let's go ahead and just write that down one more time. And then here we have the dx. Alright, here comes the best part. Because to integrate a power series, all we have to do is to use the reverse power rule right here. And that is just go ahead and add 1 to the power, and the new power is 6n plus 4, and divided by the new power here. I ran out of space, so I'm just going to put that down in the final answer. So here we go. By the way, remember that when we integrate anything, we should put down a plus c at the end. But I'm not going to put down a plus c at the end because that will look like the series and then the c is inside of the series. So we don't like that. Let's put on c plus first, okay? And then here we go. Integrating this, so the integral is done already because we did that already. So we have just the series, n goes from 0 to infinity, and then we have -1 raised to the nth power over, remember to divide it by the new power here, which is the 6n plus 4. And then we still have that. They're just the coefficients, so they stay. And then here, x to the 6n plus 4. And that's pretty much it. How easy is this, right? And remember, the theorem I told you guys in class, whenever we integrate or differentiate the power series, the radius of convergence stays the same. We just have to double check the convergence at the endpoints of the interval convergence. But sometimes that would be too crazy, so usually we just like to talk about the radius of convergence. But this is infinity, so absolutely no worry. I'm just going to put down r is infinity here, and then we are done. This right here, it's a very famous integral, the integral of e to the -x squared. And if you go from -infinity to positive infinity, that's called the Gaussian integral. But let's see how we can take care of this with the power series. Well, let's look at the power series for e to the x, which is the series as n goes from 0 to infinity. And for e to the x, it does not alternate, and you are going to have all the factorials. So just have 1 over n factorial, and then x raised to the nth power. That's it. R is also infinity. And now we have to have -x squared in here. So let's go ahead and make that happen. E to the -x squared. This means we have the series as n goes from 0 to infinity, 1 over n factorial, parentheses, with that inside here, and then raised to the nth power. Fix this a little bit, we see that here we have the series as n goes from 0 to infinity. Here we have this factor, negative 1 to the nth power. Let's put that in the front first. And yeah, in the end, this becomes alternating thanks to this negative. So we have the negative 1 raised to the nth power and then over n factorial. And then here we just have x to the second and then to the n, which is just 2n. And again, similar to earlier, this r still stays infinity. Very nice. So to integrate this, we just have to look at the integral and we have the series. The best part is go ahead and just add 1 and the new power is 2n plus 1 and remember to divide it by the new power. And let's put down c plus first. And we have the series as n goes from 0 to infinity and we have negative 1 raised to the nth power over 2n plus 1 and then times n factorial. Usually you want to write this down first before the n factorial because if you have the factorial right in the middle, that doesn't look that nice. But anyway, here we have x to the 2n plus 1. That's it. And then when we integrate a power series, the radius of convergence stays the same. So r is still infinity. And then that's it. Number 3, we are going to integrate x times cosine of x to the third power with power series. So here we go, starting with cosine first. And of course, I will tell you guys how I remember all the power series. Here we have the series as n goes from 0 to infinity. Remember that cosine is even, and this is very similar to sine. Cosine and sine, they are always the best friends. It also alternates, but we have all the even factorials and also the even powers. So we are going to have negative 1 raised to the nth power over all the even factorials, and then we have x to the even power. So we have x raised to the 2nth power. Yep, just like that. And then, of course, the radius of convergence is also infinity. So remember, e to the x, sine x, and also cosine x, all their radius of convergence are infinity. All right, and then we just have to get that happen, right? So first off, we see that we have to multiply this by x. So actually, let's do it in this way. Let's get this done first. So we have cosine of x to the third power, and this means we're plugging x to the third power here, right? So we have the series as n goes from 0 to infinity. And again, just write this down again. Right, 2n factorial, and then x to the third power, and then raised to the 2nth power. However, we do have an x in the front. That's totally okay. We're just going to multiply by that. Just like that. And then, of course, we just have to fix the exponent and all the good things. So right here, perhaps we can see that this times that is just going to be 6n. And of course, we can just multiply the x in. So all in all, this right here is going to be the series as n goes from 0 to infinity. And this right here stays. And we have x. This right here is 6n. But this is x to the first power. So you are just going to add that 1 right here. Okay, so here we have the power series. And now we can go back there and integrate. By the way, notice if this was x to the second power, we really don't have to do anything like this, because we could have just done this integral if this was x to the second power just by use up, right? But unfortunately, with x to the third power, we will have to do some approximations. Alright, no complaint, because the integration with power series is actually much easier if we know the power series. Add 1 to the power. Remember back in Calc 1, you guys all had that dream. Can I just always use the power rule? Here's the time. If you ignore this, this is the time. Anyway, the new power is 6n plus 2, and just don't forget to divide it by that later on. So here we have c plus, and then we have the series as n goes from 0 to infinity, and then we have negative 1 to the n over 6n plus 2, and then we have 2n factorial, and then lastly we have that, which is x to the 6n plus 2. And then we're done. Again, r is very nice because it is infinity. Next, we are going to integrate ln of 1 plus 4x. Yes, we can just do the usual integration by parts for this, but do you really want to do integration by parts? I don't think so. Let's just do power series. So first off, we have to look at the power series for ln of 1 plus x, and this is how I remember it. Of course, this is a series as n goes from 0 to infinity. This right here alternates, so we have -1 raised to the nth power. And in fact, this is just the result after we integrate the alternating version of the best friend. So we just have the n plus 1 here, and then x to the n plus 1. Yeah, that's pretty much it. So remember, the best friend is 1 over 1 minus x. And when we have the plus right here, this is the alternating version, we get the series of -1 raised to the nth power x to the n. Integrating this, we get that, and integrating this, we will get that. And you see, we can just add 1, divide it by the new power, and that's it. Now, the radius of convergence for this right here is 1. No problem on that. But be really careful, because right here you see that we have the 4x. So let me show you guys this right here. The radius of convergence is equal to 1. This means the absolute value of x is less than 1. And you see that we have x minus 0 technically, because the center of the power series is equal to 0. So it's technically x minus a is 0. So that's what we have. So keep this in mind. Alright, now let's go ahead and figure out the power series for ln of 1 plus 4x. And now we can just put the 4x into here and also here. This is the series as n goes from 0 to infinity, and we have -1 to the n over n plus 1, and we have to put 4x here and then raise to the n plus 1 power. We are going to separate this because you know later on when we integrate, we really want to look at x to the some power part. So let's focus on that first. We get the series n goes from 0 to infinity, and we get -1. Here you see that we still have the nth power. We have 4 to this power, so let's put that down. So 4 to the n plus 1 power over that, and then x to the n plus 1 power. Always just kind of put the x on the side. Okay, what's the radius of convergence? This is the time that we have to utilize the inequality here. We are going to put the 4x in here. So the absolute value of 4x, this right here, has to be less than 1. Solve this whichever way that you want, but to do it in a detailed way, you put the 4 on the outside first, and then divide the 4 on both sides. So you see, we have the absolute value of x is less than 1 over 4. This right here tells you the r. So I'll just tell you r is equal to 1 over 4. Alright, so be really careful, especially when you have a finite radius of convergence. Sometimes if you have like a number in the front and things like that, you will have to work it out carefully. Now, here's the best part, right? We're just going to put this back there and then integrate. Now, of course, go ahead and just add 1 here, and the new power is n plus 2. So, ladies and gentlemen, we have the series as n goes from 0 to infinity, and we have all this. It's just a lot to write. It's really not that bad. And then 4 to the n plus 1 over this down here. So we have the n plus 2 times n plus 1, and then x to the n plus 2. And yes, I forgot the c plus in the front, but let me just put that down right here, c plus. And r is also 1 over 4, because remember, when you integrate a power series, the radius of convergence stays the same. Alright, so that's it for that. Alright, number 5, we are going to integrate x over 1 plus 2x to the 4th power. And the truth is, we can actually just do some u sub for this integral, but you know what I'm going to say. Do you really want to do u sub? Maybe yes in this case, but no, we're still going to do power series. So check this out. We are going to start with our best friend. So, or you can actually just start with the alternating version of the best friend. It really depends on your preference. But of course, you can never go wrong if you start with your best friend for the rational functions. So let me do that right here. This right here is equal to the series as n goes from 0 to infinity, and we just have x to the nth power. And I'm actually going to put down not only r is equal to 1, but this right here, because r is finite, let's actually write that down as well, just like what we did earlier. The absolute value of x is less than 1. Alright? So this and that, they mean the same thing. But use this because we have to figure out the new radius of convergence for that. Okay, over there we have the following, which is x over 1. We have the plus over there. Let me actually just put down everything, plus 2x to the first power. Let's play the game, mix and match, so we can use the best friend. How? First, we need to have a 1 on the top, so let's put the x on the side, like this. And then, you see that we have the 1 right here. That match with that, that's good, but this is a minus, this is a plus. So that's right here as minus minus. So we will get 1 minus, and then we get the minus negative 2x to the first power, like this. Yeah. Okay, we can plug in this into here now, so we get x times the series as n goes from 0 to infinity, parentheses, with negative 2x to the first power inside, and then raised to the nth power. Work this out real quick. You see that this is going to be the series as n goes from 0 to infinity. Let me write down negative 2 to the nth power. Depends how you want to write it. You can just write down negative 2 to the nth power. But you know, we like to look at negative 1 to the nth power as the alternating factor, right? So perhaps let's put it as negative 1 to the nth power, and then 2 to the nth power. I'm doing that on purpose. And that's it, right? No denominator for now. And then we have x to the 4nth power. But you know, we can put this and then multiply the inside, so you just add a 1 right here. So ladies and gentlemen, this is the form of the power series for that. But we also should put this right here inside of the absolute value inequality. So absolute value of negative 2x to the 4th power, this has to be less than 1. Absolute value of negative 2 doesn't matter, the negative, so we just have 2. And then absolute value, we can put the 4th power on the outside. That's the property of the absolute value. And of course, divide the 2 on both sides, so we get absolute value of x. And of course, take the 4th root after that, so this is less than 1 over 2, and then you take the 4th root. And you can just put it down like this. Or if you would like, this is 1 over the 4th root of 2. So, yeah. So, with that said, this right here is the radius of convergence. So, r is equal to 1 over the 4th root of 2. Okay, all done with that. This right here is the fun part. Ladies and gentlemen, to integrate this is just the integral. You know what we are going to do. Go ahead, add 1, 4n plus 2, and divide that a new power. And this time, remember the c plus, and then the series as n goes from 0 to infinity, negative 1 to the n, 2 to the n, over that new power, which is 4n plus 2. And then x to the 4n plus 2. And finally, the radius of convergence stayed the same. So r equals 1 over the 4th root of 2. And then with that, we are done. Okay, last one. We are going to integrate x to the 3rd power times inverse tangent of x. Go ahead and use integration by parts if you would like, but we'll use power series. Okay, we just have to look at this right here, right? Let me recall. Inverse tangent of x. The best way to remember this is that this is almost the same as the power series for sin x. Just that you don't have the factorial. That's that, right? So you get the alternating factor here, and then you have the odd denominator. In fact, inverse tangent is also odd. And then you have x to the power of 2m plus 1. And another thing that's different is that the radius of convergence is equal to 1. Okay? And the reason is because for this, it's actually just the result after we integrate 1 over 1 plus x squared. And r right here is 1. Integrating this, r is still equal to 1. These are the only two differences between this power series and the power series for sin x. Okay, and you see I just put on r is equal to 1 because I don't have to plug in anything into the inverse tangent. But instead, we just have to multiply by x to the 3rd power. And you know, when we multiply by this, we can just put this and multiply with that and just get a new power. So we get series n goes from 0 to infinity, and we have negative 1 to the n over 2n plus 1 x to the 2n plus 4 r still equal to 4. I mean 1. Why did I say 4? I have no idea. Alright, so now we will see this is the integral. Ladies and gentlemen, here is the best part. Go ahead, add 1 to the power, new power, 2n plus 5. Divide that, and don't forget c plus. And then series n goes from 0 to infinity, this on the top, over that right here, 2n plus 5, and then 2n plus 1, and then x to the 2n plus 5. Finally, just put on r is equal to 1, and then we are done. That's that. So hopefully this video gives you the idea of how we can integrate a power series, and hopefully this right here helps. If you guys need more videos on Calculus 2 tutorials, check out my other videos, check out my playlist. I'll see you guys over there. That's it.